All right, I have 10-10. Let's go ahead and get started. Again, this is Math 266, Calculus 2 for engineers. Just want to make sure that you're in the right place. My name is Stephen Reese. I'll be the teacher this semester. A little about me. I've taught this class several times, including just last semester. But I've been teaching calculus in some form for the last 10 years, either high school or here or at the community college level. I'm currently a fourth year PhD student in the math education program. So I've been here a bit. I've taught this class a few times, but I don't claim to have this mastered. So if there's anything you need, any support you need, or if you need something explained, whatever, anything you need, please let me know. I'm very open to talking with you and kind of supporting you however you need it. That's a point that I will stress many times, especially early on in the semester, but this is a tough class. You've probably heard from other classmates, previous students, that it's a tough class. At any given time or at certain times throughout this semester, you will all need help with something. You will all struggle with something. Please reach out to each other. Please reach out to me. It's very learnable. It's doable, but that doesn't mean it's easily doable. So keep those lines of communication open, and I'll do whatever, get you whatever support you need. Make sense so far? Okay. So we'll get into a little bit of math today, but first I want to kind of go over some of the important parts of the syllabus. So, by the way, as I'm going through this, I don't think it's a safe assumption that you can all access my Canvas or syllabus, textbook, all that stuff. If you have tried to access my Canvas, first of all, or the textbook or web work and not been able to, I need to know that as soon as possible. Seems to affect a couple people every semester. So let me know if that affects you, and I'll do some troubleshooting as soon as I can. But let me go ahead and open the syllabus from here. So I'm not going to go over absolutely everything, but I will hit the things that I think are most important. So one thing that probably annoys me and probably annoys all of you is that my office hours are not set right now. That won't happen until like the second or third week of the semester. But in the meantime, and even after that happens, please make appointments with me. So whenever my office hours happen, I'll be in the MCC, which is room 303 upstairs on third floor, which is, if it's not a place that you've gone to before, I highly recommend it. It's not well known, but it's a very useful resource. So basically, there are so many tutoring centers on campus, all of which can probably get you help for Calc 2. But as you kind of move along, Calc 3 and beyond, the people who can help you in those tutoring centers, those numbers drop off pretty fast. The Math Community Center is not really that way because it is staffed entirely by PhD students in the math program, which means even to apply for the PhD program here, you have to have finished like 371, which is advanced calculus and linear algebra. So we've gone through the entire calculus sequence. So I really recommend it when it opens up to start getting help there. A lot of good resources there, and even if you don't need tutoring, it's a good place to meet up and get stuff done. One thing I do want to stress is that, I do not pretend that when my office hours are set, they're going to work for all of you, but please make appointments. I'm far enough in my grad studies, which means that I'm not really taking classes anymore. And the good news for you is that even though I'm still busy, I still have a lot of stuff to do. Very little of it is scheduled. So if you need to make an appointment, those are pretty easy to hammer out. I can usually find a time to meet with you. But I really want to stress that if my office hours don't work for you, that should not hold you back. You will be able to meet with me, but we need to arrange that. The text is available through Brightwave. So if you look at the left-hand side of Canvas down here, it is Brightwave course materials. It should be accessible there. Basically, it's an ebook, and access to it is you've already paid for it. You shouldn't have to buy anything separate. I think it's 25 bucks a semester, and it basically should have been included in your fees when you enrolled in the course. What else? Very rough schedule for kind of how we're going to cover things in here. And I say rough because, you know, even though I have some experience teaching this class, if we take really long on a certain section, that's fine. We have time to do that. You don't have to wait till office hours to ask questions if you're kind of struggling with stuff. If there's something in class that's not clear, stop me. We have plenty of time to get through all this. Regardless of how many questions you have, how much we need to explain things and kind of revisit things, we have plenty of time to get through all this. I'm confident in that. So even though I'm saying this schedule is rough, the things that are set in stone are the exam dates, because this is a coordinated class and there are 7 or 8 different sections of Calc 2 going on at the same time, all using more or less the same exams, which means they have to give them on the same days. So I don't really have any wiggle room over those. Those are marked here: February 7th, March 20th, April 17th. And the final is most likely late in the evening on April 30th. I don't know the time yet. It's probably going to be 7 o'clock at night. In terms of grading, more probably standard for what you're used to. The grade cutoffs over here. ASU uses a 9-point scale, so pluses and minuses for most of your grades. One thing I do want to point out is these are minimums. And what I mean by that is if everyone gets a 90% in here, that everyone gets an A. So if you get a 90%, you're guaranteed an A. That doesn't mean that if you fall a little bit below that you're definitely not getting one. I don't want to promise anything, but I've almost always had to give some kind of adjustment just because the grades don't, just by the way things shake out at the end of the semester. But these things are more or less, these are guaranteed to you. If you wind up between a 93 and a 97, you'll get an A. Any questions so far? I'm not going to go in too much detail. The things we're going to cover the whole semester, so as to not overwhelm you, but the basics are this. Calc 1, you spent pretty much the whole time doing derivatives, right? So you started off with limits and continuity, those kind of things, built that up into the derivative and spent most of the semester doing that. Probably talked about integration for the last week, maybe. So the bulk of this class is about integration and how to apply that, what they really mean, what you're doing with them. And then looking forward, Calc 3 basically takes all your stuff with derivatives, all your stuff with integrals, and starts adding more variables to it. So how to look at things in 3D and beyond. Again, I'm gonna stress the point for office hours. If they don't work for you, make an appointment with me. I'm happy to do that. I'm happy to meet either remotely or in person, whatever works best for us. Online homework is going to be done through WebWork, which hopefully most of you have used before, especially if you've taken Calc 1 here. If you have not, I'll talk about how to get to it. Quizzes, this is kind of boilerplate from the syllabus. I don't really use quizzes in here. We'll talk about the kind of assignments you can count on having to do in here, but quizzes are not among them. I think the rest of this is a boilerplate. Graphing calculators, I do allow them for use on my tests. The only thing to keep in mind is that if they have like that CAS, that computer, basically, I'm not sure exactly what it stands for, basically it can solve algebraic equations on its own. That's the only thing we kind of prohibit during tests. I have no problem using those things for your homeworks, but if that's your only resource, you won't be able to use it on test days. If you want recommendations for something you can use, let me know. Like these TI Inspires and 83s, 84s are pretty expensive, but there are some cheaper options out there. Email, I don't really. So if you send me an email from your personal account, which many of you probably prefer to use your personal account than your ASU account, I'll probably not respond to it there. I'll probably respond to your actual ASU email. but just that's something we have to do. One thing I have not used a lot in the past, which I'm going to stress a lot more this semester, is ed discussion. Have you ever used ed discussion for previous class? Basically, it's kind of it's a virtual forum, and the thing I would most like to use it for this semester, where I think it'll be most useful for you, and to a lesser extent me. So like I said, this is a tough class. I get emails from students on a regular basis. Hey, I'm having trouble with this this online homework question, or this question. Can you give me a hint? And the thing I'm trying to avoid is, if it's hard for you, it's probably hard for 9 other people. And rather than me kind of give that guidance to everyone individually, I would like to see those kind of get crowdsourced. And what I mean by that is, if you post those whatever you're struggling with, whatever question you have to that online forum, other people can weigh in. And that doesn't mean if no help is forthcoming from, maybe it's something the entire class is just lost on. That tells me 2 things. One, I didn't cover it well enough, and B, I need to go revisit that, and I need to give that guidance to everyone. But rather than me answering 10 individual emails, I can kind of put that guidance somewhere where everyone can see it, and it'll be there forever. And I'll bring that up in a second to show what it looks like. But if you do send me an email with a question about homework or something, or looking for help, I will probably ask you to redirect it there, just so we can get this thing kickstarted. A few hints I can give you to kind of be successful. I'm not going to ask you to turn notifications on campus. I mean, if there are some people that just get overwhelmed if Canvas is barking at you all the time, especially if you have it set up for all the classes you're taking. So I'm not going to necessarily ask you to turn those on, but please check it on a regular basis, at least once a day. I will put announcements on there if I extend the deadline, which I do quite a bit. I'll make an announcement there. But due dates are on there. After homework assignments are due, I'll usually post solutions on there. So make sure to check it. I do update it at least after every class period. I update it. So make sure you're taking a look at it regularly. Attendance is not something I mandate, but it really serves you well to be here as often as you can be. I do record all of my class meetings. I'm recording right now. And I post those to Canvas and to my YouTube channel. But you can't get your questions answered that way in class. So if you can at all, please be here. And if you can't, let me know. I'll work with you to get you caught up, or to kind of make sure you can stay on pace. But yeah, let me know if there's anything that's keeping you from being here, especially if it's going to be over a long period of time or on a test day, things like that. Again, just keep the lines of communication open. I'll do whatever I can to help. I think that's it that I want to talk about from the syllabus. Let me kind of walk you through Canvas to kind of talk about the kinds of assignments that I'm going to give, and basically what we can expect from each other. So I showed you the syllabus. I'll open up that ed discussion. This might look different for me than it does for you, but hopefully not. Hopefully we all kind of have the same view. But basically, if you open up ed discussion, which is basically along that left side of links on Canvas, you should see ed discussion, and it brings up this forum. As far as I know, the only post in there is mine, basically just asking people to use this thing and to basically not if you need help, when you need help. I mean, I'm not trying to scare anybody. I'm really trying to liberate you. Don't get down on yourself. Don't feel bad when things get hard, because they will. It's a tough class. Go ahead.
Would we ask our questions where it says add comment right there?
So not necessarily to this one, but like, let's say you do have a question. Let's say it's on online homework. I would go in here and can I put a thread in here? Yeah, new thread. Help needed section 5.5, question 5.4, whatever. So I'm answering this question for you as well as myself. I have not done this yet, but basically, yeah, okay, that's as easy as it is. So just, yeah, go to whatever section. So right now my headings are for, general things that happen in class, sections of the text in general, online homework, written homework. But I have not used this extensively before. If there are new headings or if there are other headings that are worthwhile to throw on here, I'll either tell you to do it, or if you can't, I'll put new headings in there. So apparently you can access this because 3 people have already looked at it. Can I delete it because it's just accessory?
There's a delete button right there under your thing. Like,
Oh, there it is. Excellent. So thank you for teaching me how to use the thing that I'm telling you we're going to use. All right. So yeah, I appreciate it a lot if we could make extensive use of this. I think it'll be valuable, and I think the most value that's going to come out of it is the fact that, let's say you individual send me an email on a thing you don't understand and I answer you. I'm not trying to put anybody up. I think this is true for everyone in here, me included. When you struggle with something, there's that voice in your head that tells you, I'm the only person who doesn't get this. And hopefully by putting it here, or by seeing somebody else put something here, you will realize, oh no, this is just the struggle that kind of goes with this. But yeah, I really think it's going to be useful for all of us to use this semester. All right, what kinds of homeworks am I going to use? So aside from the test, the 3 midterm exams and the final exam at the end of the semester, the big things that I'm going to use are web work, which webwork.asu.edu. Is this something you're familiar with? Okay, so webwork.asu.edu under Math 266, I'm near the bottom. This is going to look different for me than it does for you, but hopefully when you open this up, it'll just show you the homework sets that I've actually assigned you, which right now will be none. I don't usually assign them until I start covering them in class. But they'll show up here. If you can't access this, I need to know. Tell me right away. It should be an easy fix for me, but yeah, I don't know you need help unless you tell me. But like I said, I haven't assigned anything yet just because I don't usually send those out to people until I start covering things in class, which I'll do soon. The other thing so in addition to the online homework, the web work, I use, I assign written homeworks as well. So probably about 10 or so this semester total. And basically the reason I assign those is because I think the web work, they're really valuable for getting feedback right away. The problems are usually very short. So basically what I do with the written homework is ask a few things that are a little more in depth. And these also give me an excuse to give you more detailed feedback on things and for me to see basically like see if there are kind of global things that I need to revisit more strongly. Whereas the web works, all I can really see is if you got the wrong answer on a certain question, it doesn't really tell me what you didn't understand or what the deficits are or how I can help. The online homeworks really give me a better idea of that. So, and since I've had people tell me this concern before, I do delete about a quarter of the web works before I assign them to you because I also do this. So I'm not trying to make you do twice as many things. I'm just trying to vary kind of the presentations that I show you. So the first written homework assignment is already posted. It covers the first couple of sections, and I don't remember if I already put a due date on it, but it's, I think, probably middle of next week sometime. But again, if you're not able to see these things, let me know as soon as you can. Any other questions? Go ahead.
Do we have to print it out or do we like label a fresh piece of paper?
No, that's a good question. So in fact, the first semester I taught here, I tried to do the written homework based on give people the option. You can either upload it to Canvas or give me a paper copy, and no one ever turned anything on paper. So just basically do it in your notebook, paper, whiteboard, I don't care. But basically you'll be uploading like PDFs or images to this. So basically, yeah, so you're submitting a file upload. So I don't restrict the kinds of files. So images or PDFs, whatever, they're all good. As long as I can download it, I don't care. What else? Okay. Is there anything else I gotta tell you about? At least a couple of you let me know you could not see the textbook early. Has anybody been able to see the textbook yet? Okay, good. So I think that they just whatever Canvas, Brightwave, they just didn't make it available until today. So it sounds like that cleared itself up. So that's good to know. But sorry. So the good news is that no one's telling me so far that they can't see anything. So hopefully that's the case. If you do find you have problems later, let me know, and we'll get that taken care of. Anything else? Go ahead.
Do you do exam reviews?
Beforehand?
Yeah.
So almost always, I don't want to promise them just in case, like I said, it's a coordinated class. So if there are things that we still have to cover, we'll do that. But so I taught the same class last semester, and on the day before the class period before every test, I pretty much got to use that full time. And what I've always done for exam reviews, and will continue to do because I think it's works better for all of us, is I'll let you bring in whatever questions you have. Basically, we'll spend out that 50 minutes talking about whatever you all say is the most important. So something I will do in the weeks, maybe the week and a half before each test is, because this is a coordinated class and it's been taught so many times, there's a wealth of review questions and stuff from past tests that I can share with you. Things I can post to Canvas that are just like, I put them in the quizzes because I have to put them somewhere, but basically they're just like banks of 30 or 40 past exam questions that you can kind of go through. In the past, those are the things that I typically end up talking about on those exam review days. So I don't want to promise them, but I almost always have time to do them. What else? Okay. Shall we do some math? All right. So I believe and I hope that at the end of Calc 1, you talked a little bit about integration. Maybe how to take antiderivatives of polynomials, or maybe even like if I asked you to take the integral of the square root of x, because that's something you could do right now. Okay. I haven't taught Calc 1 in a while. I can't remember kind of where you end up. But let's get going. So I believe you probably ended up with section 5.4. We're going to pick right up at section 5.5. Talk about something called the substitution rule. So before we get into that, let's go back to derivatives just to kind of motivate this. Is this something right here that we could take the derivative of? What is the derivative of this thing? Or better yet, how do we approach this? Okay, so I'm hearing a lot of chain rule. What about this tells you that chain rule is a good approach?
inner function.
There's an inner function. What is that inner function that you're seeing? 3x squared minus 5. Okay, so let me call that g of x. Okay, so we have an inner function, which means we probably have an outer function that kind of that g is contained in. What is that outer function that g is contained in? Right, so we're taking that inner function and we're raising it to the power of 7. So if I'm going to set up chain rule, I need derivatives of both these things, right? And they are what? Okay. So how do all those things come together to give me a derivative of f? Seven times 6x to the 6th. 7 times 6x, like this.
Might be messing up.
Yeah, so
7 times the inner function, 3x squared minus 5 to the 6 times 6x.
okay. So, and this is something I kind of expected. I mean, knowing that we have to use the chain rule is a lot more common than kind of understanding how all the pieces go together. But in general, you've probably seen something like this. That if I have this, if I want to take this derivative, then that is basically the derivative of the outside function. But what is the input to that function? It's whatever the inner function is, and then multiplied by the derivative of the inside function. Or you've probably seen this Leibniz notation. The derivative of the whole thing is equal to the derivative of h with respect to g times the derivative of g with respect to x. So why am I talking about chain rule? So basically, the one thing I want to point out here is many of you at once said chain rule. So just a reminder, what was the thing that tipped you off that was the way to go? So you have some kind of inner function, outer function. What's the more mathematical vocabulary term for that kind of function? You hear a lot of mutters. Not confident? Yeah, composite function. So basically, we're going to do the same kind of thing, except now we're going to go integration though, we're going to undo it. So you should be able to tell me the antiderivative of the function I have up here, right? It should be exactly where we started last time, right? So we didn't simplify it, but that is 42x times 3x squared minus 5 to the 6th. So that's kind of the goal here. We're going to take the chain rule, which is a thing we've done for a long time, to find derivatives, and we're going to undo it to take integrals. But again, the idea is to look at these inner and outer functions. So before I kind of get into how to do this for integrals, do we see anything in this function here, this thing that I want to integrate? Do we see anything here that I might call an inner function? What is that to you? X to the 4th plus 2. I'm going to call that u. So u equals x to the 4th minus plus 2. So this is not something we can integrate because we just don't have access to it with the integration tools that you have right now. So basically what I want to do is this. I want to take this integral, which is taking a function of x and integrating it with respect to x. And I want to do this. I want to turn this into an integral of a function of u and integrate it with respect to u. So u is this. Basically, I'm bringing in a new function to handle, basically to substitute for this inner function. So I have u equals x to the 4th plus 2. So here's the consequence that comes from that u. when you find an integral, how many variables are inside this integral up here? I'm hearing ones, I'm hearing twos. So the one that's probably more obvious is x, right? The one that's probably less obvious is as a distinct variable is that dx. So we have, static values of x, but we also have this dx, which is just a little tiny change. If you think about the way you learn integrals is like a Riemann sum, you take an area of a bunch of rectangles, add all those areas together. Basically with that dx, that represents just a very, very small change in the thickness of those rectangles. But it's a variable we have to account for. So why does that matter for us? I have u equals x to the fourth plus 2. So I've already I've kind of started dealing with getting a function in terms of u, but now I got to get this du. So I'm going to take a derivative. What is du dx?
4x cubed dx.
4x cubed.
Dx.
Well, okay, I'll get there. Which means the du is equal to 4x cubed dx. So I have a u, I have a du. So the only way I'm going to be able to find this integral by substitution is I want to get all the x's out of the integral and basically transform it into an integral that's in terms of u and du. Can I do that? So let's do it in pieces. Let's start rewriting this integral. What's a replacement or a substitution I can make based on the things that I've made, the things that I've kind of defined here. So x cubed cosine of u dx. So I still have some stuff to worry about, but that's a good first step. How can I handle the x cubed and the dx? Okay, so a couple ways, and I'll show you both. I'm sure one will probably make more sense to you than the other. But dx is equal to du over 4x cubed, right? Which means this is equal to the integral of x cubed cosine u times du over 4x cubed. So what happens with that? These annihilate, and I have what? The integral of 1/4 cosine u du. So the goal that I mentioned was I wanted to get my integral totally in terms of u. Are we there? Good. Is that an integral that we can take? What's the antiderivative of 1/4 cosine u? 1/4 sine of u plus c. So very close. The last thing I'm going to ask us to do is, since we started this process with an integral or with a function that was defined in x, let's get back there. So 1/4 sine of what? Right. That is what we called u. Still true. So here's our. So one thing I need to get used to is this room. This room is a mirrored image of the one that I taught in last semester. So I was looking left the whole time. All right. So this is our first pass at integration by substitution. Any questions on how this works? What the goal is? Shall we see another one? Let's put some formality behind it. So this u is essentially the thing that most of you are thinking about as the inner function. Calling it g of x, but condensing it into a single letter u. If I have some differentiable function on some interval that u, and f is continuous on the same interval, then I have this. So you've seen this before, right? What is this? That's the chain rule going the derivative way, the thing you learned in Calc 1. But if we take the inverse of that, so We said this g of x was u, right? What is this right here? This is du. So basically we're using that as a kind of a translation map to take our integral from a form we can't really deal with it in to a form where it's hopefully simpler to deal with. So one thing I forgot to mention is that before every class, well, right now, if you go to my Canvas, I already have the slides up for this section and the next one, because that's what I'm guessing that we'll get to this week. After every class period, I post my like marked up slides. So, and the reason I say this is because at some point you're probably going to have the impulse to pull out your phone and take a picture. If you don't want to do that, you don't really have to, because I will post these. All right. Same goal here. I want to take an antiderivative of this or integral of this by substitution. So I want to ask myself if I see an interfunction. So I'm hearing 2x plus 1. And I think I know the answer to this, but I'm going to ask it anyway, just to kind of put it out there. What's the big thing we look for when we're trying to figure out the inner and outer function thing? What's like the biggest indicator that you're looking at it, that you're looking at a composite function? Parentheses typically, right? Which I don't technically have here, but I do have an expression that I'm doing something else to. So I have that inner function 2x plus 1. Well, let's see if we can take that. Let's see if we can use that to set up this integration by substitution. So the consequence that comes from us defining u is that we don't really have a choice over what du is. So what's du going to be for us based on 2x plus 1 for u? 2dx. So this is the kind of these two equalities here. We're going to try to use this as a translation map to rewrite this whole integral. So what does this integral become? So the integral of radical 2x plus 1 dx equals what?
Rule of 1/2 square root of u dx.
Integral of 1/2 square root of u dx. We okay with that? Are we done?
What do you?
Should it just be du?
Oh,
Okay.
for the du, yeah.
Okay. So I believe, yes, this is the right way to go. Just because we're new to this, let's kind of break it down a little bit. So I know this right here is the square root of u dx. Where did that 1/2 come from?
Balance the du equals 2 dx. So
Right.
Have 2 dx.
Right. So one thing we can do here is, and there's a lot of ways to make this manipulation. But if you realize that the radical just becomes radical u, and you're still left with the dx, can I solve for dx here? Dx equals du over 2. Or 1/2 du. But that's typically a manipulation you'll have to make, is because, so with chain rule, you have full freedom over what your inner function is, right? And you kind of have a lot of freedom over what your outer function is. When we're doing integration, you really need u and du to be related in a very specific way. One has to be a derivative of the other, or not quite a derivative of the other, but some kind of a multiple of the derivative of the other. Which we've seen this example in the last one, we had to divide by a constant to kind of get where we wanted to go. So now, is this a derivative we can handle? Or sorry, an integral we can handle? What is the integral of, and by the way, if you'd rather, we can also do that. You can pull out constants. What is the integral of radical u? I heard 3/2 and then a letter trailing off.
Thirds.
Oh, I see what you're saying now. Okay, so u to the 3/2 over 3/2, right? Multiplied by 1/2. We simplify that a little bit. Should be 1/3. Also, let's go ahead and undo the substitution. So 1/3 times 2x plus 1 to the 3/2 plus c. Questions? Go ahead.
Do you care in the final answer if it's written in like radical form or if it just has like to the power?
No, I don't. And that's true in general. As long as it's equivalent to the right answer, I don't have any preference at all. I don't know how you state it. Any other questions on this? Okay. All right, what question? Sure. How should we start? What do we ask ourselves? What do we set up? So we have a idea for u, 1 minus 8x squared. How do we choose that?
We have to solve that before we can solve the square root.
Okay, so you're talking like an order of operations kind of thing?
Yeah.
Okay. So because of that, basically you can treat the what's inside the radical as a bracket, as a parentheses. Because that's the thing you have to deal with first. We're okay with that choice of u. All right, so what comes from that? So what's a consequence of that definition?
Yes.
Okay. Okay, I agree with that. Right, if you solve for dx. All right. So I believe all these things are good and true. All right. Can we go forward with, this set of equalities? What do we do with those now?
And substitute the u.
Okay, so let's do it in pieces. I'm going to have x over square root of u dx. So that's a positive first step. We also have dx equals negative d over 16x. So let's try that. Yep. Oh. So x cancels x. And I have the integral of negative 1 over 16 radical u du.
Take the lot the negative 1/16 out.
Okay. So let me do that, and then we'll take a pause to make sure that we're okay with how we ended up there. So negative 1 over 16 times the integral of 1 over radical u du. So I believe, so we're not done, but I believe the integral the substitution has been finished. We took an integral that was expressed in x and dx, and now it's expressed in u and du and nothing else. So any question about how we got there? It's a lot of algebraic manipulation that kind of cleaned this up as much as it did. Do we know what the integral of 1 over radical u is?
2 square root of u.
How'd you get that?
I did the u to the -1/2.
Okay, and that's what I've been hoping would come up. I think it's harder to deal with these things when you leave them in radical form. So let's, whether or not you need it all the time, I think it's worthwhile to see it at least once. This is u to the -1/2 du, right? So what's the integral of u to the -1/2?
2 u to the 1.
Right, so it should be u to the 1/2 over 1/2 or 2u to the 1/2. Let's put the final answer up here. So we get -1/8 times the square root of 1 minus 8x squared plus c. How we doing? Okay. I got time for one more. Yeah, let's skip that one and do this one. The integral of cotangent x.
Cosine of x over sine of x.
Okay, so I got to vote for redefining this, or at least re-expressing it. Cosine of x over sine of x dx. Do we have an inner and outer function here? What is our inner function? Oh, I heard x and I heard sine of x. I think if we use u equals x, not much will change. But let's try u equals sine of x. And this probably doesn't have inner and outer function the way that you usually think of them. Usually when we think of composite, we take some x value, run it through this function, and then run whatever that output is through some other function. Like we have this series of steps. I don't think this really behaves that way, but we can still use substitution on it. If u equals sine of x, what's du equal to? Cosine of x dx. Does that help us? So what does this integral become in terms of u's and du's? Is it just du over u? Is that an integral that we know?
Yeah.
What is it?
Natural log of the absolute value of u.
It's the natural log of the absolute value of u plus c. Or the natural log of the absolute value of what? Sine of x plus c. So they look like straight lines up here. So the other examples we've done, I think we all the thing you suggested was the most direct way to do this. I think there's another way. What would have happened if we called u equals cosine of x? Does this work?
Yeah.
If u equals cosine x, what's du? Then what does this become? Is it just negative u over du? Is that something we can integrate? Not really. So one thing, I don't know how explicitly was brought up in Calc 1, but remember the integrals we do are based on Riemann sums, which are really just rectangles. I want to multiply the height of the rectangle, which is like my y value, by the little change, how wide the base is. That's usually a change in x, right? that has to be a multiplication. So because of that, I need my dx or my du to be something I'm multiplying by the function, not something I'm dividing by. So, and that was the last little trap I wanted to make you aware of, is that when you find your u and du, that du needs to be something united, like basically has to be related to the function through multiplication, not division. Anything else? All right, good first day. I'll see you on Wednesday.